If you're trying to create custom metrics out of your code, then this episode is for you. Welcome to Is It Observable? Today's episode is part of the OpenTelemetry series where we already covered several episodes. We had the introduction to OpenTelemetry, what is OPAMP, how to observe your Kubernetes cluster using OpenTelemetry, the value of the OpenTelemetry operator, how to instrument your code using OpenTelemetry, and in fact, way more. Today's episode will be focused on how to use OpenTelemetry Metrics. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We'll start, as usual, with an introduction explaining what is OpenTelemetry and specifically OpenTelemetry Metrics. We will look at the various types of metrics provided by OpenTelemetry Metrics. We will then explain the main components required to create metrics with OpenTelemetry. We will look at the metrics that are included with the AutoInstrumentation library, and like usual, we'll jump into the tutorial. Like explained in the episode introducing OpenTelemetry, OpenTelemetry is an open standard for our telemetry data. The OpenTelemetry community started with the support of traces. Currently, all the languages provide a stable versions on traces except PHP and Rust. So here is the current status on the various languages supported by OpenTelemetry. As mentioned in several episodes related to OpenTelemetry, with a vendor-agnostic library, you are free to build your custom telemetry data, traces, metrics, and soon logs using the right OpenTelemetry SDK. With an agnostic library, we are sure to control the cost related to the future tool changes, because we're not adding any vendor locked-in library anymore in our code. We are used since decades to build logs using a logging library out of our code. The idea is a bit similar, but here using OpenTelemetry. Some projects used to track in the logs with the severity debug or the start and end function. You can imagine to do the same thing but slightly differently. For this use case, it would make more sense to create a span to track each functions created and eventually add OpenTelemetry logs for other details. With the recent support of metrics, we can now think of building your metrics from your code. It could be a technical KPI like the number of query going through GraphQL server, or functional, the number of search by product observed in our websites, or even a business metrics like the number of order with a valid payment grouped by payment methods and geo. But this is not new. We were already being able to create our custom metrics using the Prometheus client SDK. We were able to create counter, gauge, histograms, and summary. Yeah, you're making a good point. But here, creating metrics with the Otel SDK allows us to use a semantic convention that standardizes the naming of a metrics, the type, the units, the labels, the technology, and more. And also linking the trace context to our metrics and soon our logs. It would mean that I can look at a CPU usage and then filter all the traces that are linked to the CPU usage above 80%, for example. Having disconnected observability data won't help you so much. To be able to understand a given situation, you need to have your data connected. By connecting the trace context between traces, metrics, logs, we can add the context that we need. And if we are enriching our data with the right resources, attributes, and more, we can then index our data to a specific components of our environments like the pod, the namespace, the node, the cluster, the host, and more. With OpenTelemetry, we now have the right tools to design our observability without any boundaries. Observability to infinite and beyond! The OpenTelemetry community has worked on a specification to make it compatible with existing standards, so Prometheus and Otel Metrics. Similar to Prometheus, OpenTelemetry provides several metric types. In reality, to make sure there is a compatibility with Otel Metrics and Prometheus, OpenTelemetry provided a similar types of metrics. So at the end, we have counters. Counters are metrics that always increasing. So we can only add values to a counter, in fact, a positive value, one or more. Counters are perfect to report total. What is the value of a counter? I mean, plotting a total that just increase over time, there is no value. I cannot do anything with it. Well, in fact, you will see. Counters are often combined with a function in the observability solutions named rate. Rate will help us to convert a total into a number per second. Counters are used to report, for example, the number of requests coming in our microservices, web server, number of messages sent or received in a queue. Again, keep in mind that you will be able to use it as number per second. So in the case of a web server or a web application, you will be able to keep track on the HTTP request of a web server. You can report the number of requests per second with the help of a counter. Up-down counters. If you have any negative values that you're going to add in your counter, then OpenTelemetry has introduced a new version of the counter, the up-down counter. That is similar to a counter, but here we can add a negative value to this counter. Histogram. If you're planning to report data to then do some statistics like calculating a percentile, a percentage, an average, then histograms will be designed for that. Histogram is working with buckets. Every time we report a record, the value will be added to the right bucket. For example, if I want to record every value of a dice, so a normal dice, as you know, has a value between 1 and 6. So it would mean that in this example, I will have 6 buckets. 1, 2, 3, until 6. Every bucket will keep track on the number of values in that bucket, so the count. And every bucket will have the minimum and the maximum. With this model, we can easily imagine to create analytics to report the number of items, the average, the percentile, the percentage, and more. In OpenTelemetry, there are several types of histograms. The explicit bucket histograms, where you will need to define the various boundaries of your buckets. If you're not defining them, it will use the default boundaries. So here is the default boundaries, quite similar to the Prometheus default buckets of the histograms. The second type of histograms provided by OpenTelemetry is the exponential bucket histograms, where you don't have to explicitly define the bucket boundaries. The bucket will be defined based on the values that we are recording in the histograms. The only parameter required is the maximum numbers of buckets. And by the way, by default, it is set to 160. Exponential buckets histogram is a powerful metric type, especially when you don't really know the distributions of the values of the metrics that you are producing. And last, we also have gauge, similar to Prometheus. Gauge are metrics that could go up and down. Perfect to report memory usage, CPU usage, response times. Well, there is tons of different implementation for gauge. Similar to traces, there are objects that we need to use to be able to report metrics from our applications. The main important components would be the MeterProvider. The MeterProvider holds the resource, so it's the identity, the context of all the metrics managed by this provider, the metric reader, and the views. Once we have a meter provider defined, we can create meters and metrics at the end. Meter will hold our metrics defined with instrument. The view, which is optional, will be the bridge with our meter reader. But the view and the meter reader will allow us to apply aggregations to the metrics produced before exporting it. So before jumping into meters, let's have a look at the two elements defining our meter provider. So the meter reader and the views. Meter readers is the object that will define how to send the metric produced. Meter reader will need to have one exporter defined to send the metrics to the right destination. Technically, every metric produced will be stored in memory by the reader. Then the exporter will take the metric available in the reader to send it to our auxiliary backend of our choice. Similar to traces, the meter exporter will define where we are planning to send our generated metrics using the OTLP exporter, Prometheus, or others. The interval between each measurement and the aggregation type will be defined in the meter reader with a periodic object. View is a way of customizing the metric before sending it. For example, I can have the ability to rename the metric, change attributes, drop metrics not needed anymore, change the aggregation. For example, if I'm producing unuseful histograms, I can decide to only push the total count instead of the entire histograms. Once our meter provider is created, we can now create one or several meters. For example, let's say we want to create a new metrics in Node.js, so we will have this piece of code, where we define the resources in this example, with the name of the service, the versions, and we define the meter reader. In this case, it's a periodic exporting metric read. We use the OTLP exporter. We have a specific aggregation with delta, and then you can see that we will push the metrics every 3 seconds. Once the meter provider is defined, we can create the meter provider utilizing this meter reader and the resources. We set to the SDK a global meter provider that we initially have defined. And after that, we have the options to create a view as well. In this example, the view will drop all the metric name pops up. Once we have defined our metric provider, we can start creating a meter object. A meter object will allow us to create instruments. And instruments, at the end, it's our actual metric. A meter can have one or several instruments. An instrument will have a name, a description, a kind, so counter, up-down counter, gauge, histograms, and so on, and a unit. For example, we create a meter called Apollo server, and then we can add to that meter all the various instruments that we need. And for each instrument, we'll define the metric type, the name, the descriptions. And when we create the metrics, we will add set depending on the metric type, and we can attach the right labels that we need. OpenTelemetry community is adding to a couple of the AutoInstrumentation library the ability to produce, of course, traces like we saw in previous episodes, but also metrics. So here is the list of the AutoInstrumentation producing metrics. You can see that with lots of Java instrumentation libraries producing metrics, a couple of .NET also libraries, Python and Go. I was not able to find any Node.js library producing metrics, but if you know any instrumentation library producing metrics in Node.js, let me know by dropping a comment to this video. From the list shared, I would say that Go, Java, and .NET will be able to produce runtime metrics on the behavior of the garbage collectors. Python, .NET will provide system metrics. Go is provided host metrics with the host library. Otherwise, each framework providing a support from an HTTP client or HTTP server are usually producing metrics on the top of the trace to report the HTTP client duration, the HTTP client request size, the HTTP client response size, HTTP server duration, and server active requests. But we should see more metrics supported in the next coming month, especially with the C++ support and the Nginx plugin. Currently, this plugin produces traces, but we should expect to also have metrics produced from this plugin. In this tutorial, we will use a simple Node.js demo application utilizing a MongoDB database. We will create OpenTelemetry Metrics counter gauge histograms. This app is allowing us to create to-do lists, so adding tasks or removing tasks. So we can imagine a couple of metrics like the number of tasks created or the number of tasks removed. We can also measure maybe the time to send data to Mongo or to retrieve some data from Mongo. So we can basically try to create all those various metrics. All our telemetry data produced will be sent to Dynatrace. For this tutorial, we will need a Kubernetes cluster, the Nginx ingress controller to expose our application, the Prometheus operator, so we can send data to Prometheus as well, the OpenTelemetry operator. It will allow us to create a simple collector pipeline deployed as a sidecar proxy close to the application, but also a daemon set collector pipeline. And of course, because the data will be sent to Dynatrace, we will also need a Dynatrace tenant.
Every tutorials that we deliver at Is It Observable, there is always a GitHub repository related to this episode. So here, obviously, we are looking at the repository related to OpenTelemetry Metrics, as expected. So here, like I explained, you need a cluster, so please deploy it. You need at least 2 nodes for that cluster. And then, as explained before, we will send the metrics and the traces produced by these demo applications to Dynatrace. So if you don't have any Dynatrace tenant, don't worry, you have a Dynatrace trial link here. So you will arrive to this page, put your email address, and then a few minutes later, you will get the URL to access to your Dynatrace tenant. But once you have the Dynatrace tenant, 2 things which is going to be important for the rest of the deployment. The first one is you need to store the actual, we call it the environment URL. So basically it's HTTPS, all the Dynatrace live, .com. This is, you have to copy, save it somewhere because we will create an environment variable with this information. The second thing is because we're going to utilize the OpenTelemetry ingest API of Dynatrace, we need obviously to have access and be authorized to ingest data and utilizing that API. So that's why you need to create tokens. You will have to go to access token on the left menu, click on generate a token, and you will have to give a name. So we can say Otel Metrics, for example. And here we're going to search for ingest. So we are not going to ingest logs obviously today, but the 2 minimal scope required will be ingest metrics and ingest traces. So then you click on save. The token value will be displayed only once. So please copy the value because you will need it later. So which means you will have to save the DT URL in one variable, the data ingest token into another variable, and then once you have cloned that repo, we will have a deployment script that will do everything. And this demo utilizes this sample app is a to-do list application written in Node.js and utilizing a Mongo database. So I'm not using the default user account and password, so you can define them here. So make sure to fill and create those two environment variables. Once they have been, those variables, once they have been created, then you will be able to run the scripts with your Mongo user, Mongo password, the tenant, the cluster name, and so on. So that's the first step which is required. So what would you get out of this deployment? Couple of things. So you will have first, if you look at, so in my case, I have in this cluster, I have the Otel demo running. But what you should expect is first get the cert manager, because OpenTelemetry Operator requires the cert manager. Fluentbit is also using for logs, but here it's not the case of this demo. You will have the ingress Nginx namespace for the Nginx ingress controller. You will obviously have the OpenTelemetry Operator technical namespace for the OpenTelemetry Operator. And then you will have the to-do namespace with our demo app. So this is what you should expect. The rest, as you can see here, Fluentbit, Hipster Shop, and Otel Demo, you won't have it because we are not using it. So what do we have here, and what should you expect? Couple of things. So first, let's have a look at the default namespace. This is what you should expect. You should see the Prometheus stack plus this collector. Then in the namespace for our demo application, the to-do, first we will have the Mongo database running in a separate workload. We will have our to-do app with two containers, because we will have a sidecar collector here. So the app produce in localhost, and the sidecar will send it to the other collector. And last, we have a small K6 load tests just to make some traffic on this application, and there's also an ingress. All right, so if I now go to the app, I have an ingress. So here, this is my app, very simple application, and obviously the load test is creating a lot of to-do lists. So that's why we have a lot of items. A lot of things to do, in fact. So at the end, what do you expect in Dynatrace? If you go back to Dynatrace, this app is currently producing only traces. So if you go to services, you should see in this list only, in your case, if you have a free trial, you only see the to-do service. So you can click on it, and you will see information about the to-do service with the service metrics, the failure rates, the throughputs, and the various traces produced. So here we have the get page, the post, so we can look at one of the posts. So this is, at the end, it shows that the app is actually running and we are actually producing traces. That's the good thing. I mentioned the collector. So what do we have as a default collector? So let me bring up this file. So first, like I mentioned, we have a sidecar collector. So the sidecar collector is only basically receiving OTLP and pushing it back to another endpoint, which is the other collector, which is deployed as the daemon set. The other collector is not doing anything fancy at all. It's just receiving OTLP, traces and metrics, and then it just send it back to Otel HTTP to Dynatrace, as you see here. If you want to add Prometheus, you can add it with another exporter, with the Prometheus exporter or the Prometheus remote write. So the plugin, the pipeline is already configured to receive traces, but also metrics. So we won't have to touch it later on once we include the metrics. Now we want, in this application producing to-do component elements, we want to count basically the number of items that we're adding, the items that we are removing, also maybe the latency to save the item in the Mongo database. So there are several things that we could cover by creating those metrics. It's a simple app. Again, we could have built more complicated applications, but that's a good start. So the first thing is, if you look at this the structure of our application, our code, in this we have added the instrumentation file, which is required to run the app, which is the main page, and this is at the moment only launching the instrumentation. You can see here we're launching the node instrumentation, HTTP Express. I could have the Mongo as well, but I think that's a good start. Now, what we're going to do is add the other aspect, which is creating a meter provider and a meter reader. So first here, as you can see here, I am defining here a meter reader, which is going to send to Otel Metrics exporter. And we can see that we're using the aggregation delta. So we just send, for example, difference between the previous export. And this metric will be exported every 3 seconds. So it means we now also have the interval for the metrics. Once that is created, I didn't mention, but if you look at the manifest file, here I have environment variables for OpenTelemetry where I'm defining the resource attribute. So I'm going to use the same one, so I don't have to recreate resources. But if you want it, you can of course create your own resource attributes. So this piece here with the resource, we could obviously remove it. We don't need to define it. So we can just create a new meter provider. And then once the meter provider is created, I can add the meter reader that we have created to the meter provider, and then define globally that we are going to use this meter provider for our OpenTelemetry SDK or API. This app JavaScript is the main page. Could have been split in several pages, but here it's a simple application. And here we're going to create the meters and the instruments and add all the stuff. So the first thing is, because we are here, we are going to create meters. It means that I need to make a reference to the Otel API. So that's the first thing, because I will use it. Once I have created the Otel API, I would be able to create as a beginning function. Create a meter. So we'll say const meter, and then we're going to use the methods provided by the API. So Otel, which is a reference to the API, and then get metrics, and then get meter, and then we can create a meter name. So here we're going to do to-do list, for example. Step is once we have the meter created, we can define new variables. So because we have the meter, we can attach to it. So we're going to get const at up. So here, just after creating the meter or later on, whatever, I'm going to create the counter item total meters. And here you see I'm using the meter dot, which is the reference of our meter, create counters, and then we give a name, a description, a unit. So that's the first thing. The second counter, we're going to do the same thing. So I'm not going to follow, we don't need, counter. Okay, and that's it. So now we have the two counters created, and now we simply need to add them at the right location. So I want to add when I'm saving elements. So here you can see that I'm looking for the post request. So here's the post, and you can see here we're creating a new item. So I will be able to create it here. And in fact, the method save here has in Mongoose framework. So the method save has, in fact, you can trap the success or the error. So I'm going to just copy paste the example. So here you see here I'm saving, and then if there's error, I can also count the errors related to database. That could be also interesting. And then if it's a success, so here it's our case, I can create my counter or add elements in my counter. So here I'm adding some labels, so different dimensions, just as an example. So we are keeping every item name. So it's not very efficient. I would say just for cost perspective, we could just put the lists where that item will be placed, and then we add it. So or we can also add the database or the server, or we can have different approach. So that's for the save function. Now we want to count also the the delete, and similar to that, we have here delete, and we have the function, and we can also have the success and the error. So here we have the post remove, where we remove the elements. So you can see that we are deleting one, and we are catching the errors. But in fact, delete one has some structure, so we can basically replace that with the code as suggested. So we delete, then if it's successful, similar, we can create a label. So remove these new items, otherwise we have lots of dimensions for nothing, and then we're counting the number of elements added with attaching the label. So the gauge, so we're gonna go back to the top where we can add the two new one single variables, in fact, because at the end we want to keep track on the latency to do some operations in Mongo. So I don't need to create two different gauge. I can add just a dimension with the operation, save, delete, or whatever the operation is in Mongo, and I will just keep track that. So that will help me to only have one metrics that will cover both of the things that we are expecting. Here I have this variable here, so up. So I'm similar. So here, instead of a counter, we create an observable gauge, because it's going to be this is how it works. You gave it a specific name, a description, and a unit. Once we have this in place, then we simply have to populate the gauge. So we have to go to the save. So here it's a save. And what I want to do is to basically track on the various. I'm going to create here a variable called start. And then what I want to do is to keep the latency. So I'm going to here, before we do the actual save, which is here, I'm going to do start equal date. And then once we have saved it, which is here, I am doing const elapse, which is the difference between now and start. So now we have the response times. Next, I'm going to create also a label for this. So I can store, for example, not necessarily the items, the lists. We don't care, or we can keep track on the list. That could be interesting. But we're going to say, for example, if we have several database, but it's not the case for us because we can keep track on a database. So here the database is to do. And next we do another label, which is operation. And the operation is save. So now we have our label called label, we can say Mongo. And then similar to here, I can say, I can create my gauge metric. And then here I do add callback. And in that callback, I will have. Now we did this for the save, but we can do the same thing for removing. So here it's the same thing. So start. As a reference, you need to, of course, define the variable in the promises, the const start. And second one is make sure that the labels that are static has a quote. So otherwise you will have some compilation issues. So once it's been done, of course, build your container. So I already built mine in your GitHub, in your own Docker Hub or repo or container registry of your choice. When it's been built, push it. And very important, once you have changed it, build it. If you want to have the new updated container with the metrics, make sure to adjust the deployment file by using your image in the file located in the manifest deployment file. And then, of course, you will deploy. So I already done everything. I have the load test running. So now if I want to see those metrics, so first I can see that I have my to-do services here. I get some traffic coming in from the load test. So load test is mainly adding items, and a couple of them are removed as well. So if I want to see the metrics, remember the metrics were starting either by to-do, either Mongo. So let's search for to-do. And I can see that we have the total item created. So you can see the number of items created. So I can see it's coming in. I didn't add any specific splits, so there's no values. The other one, which were more interesting, is the gauge, the Mongo. So I think it's Mongo, and then I remember. And then we can see here the operation latency. So I can create the chart of this specific metric. And because we have labels, which means we can do a split. And in our case, we have the service name. We don't care. The scope. We have you can see that there are a couple of labels that has been added. So I can say here save, and you can see that it's the to-do list is our current is the name of the resource, and then we can save. So you can see here. We mainly have save operations, and yeah, maybe there's a crash or I need to check, but I think I set a memory limit that was a bit low, so that's why it crashed and restarted. So that's why we have the counters here. But at least we can see that the metric is coming in, and it's very simple to create the metrics. The only thing that you have to do, of course, is to make sure that you define what you want to build in terms of metrics, and then it will be very simple to implement it within your code.
That's it for today's episode related to OpenTelemetry Metrics. And it's very exciting to have the ability to create metrics directly from the code using the same SDK as the one that we use for traces. It's also really excited to see that all the effort that our community is doing to provide us AutoInstrumentation library producing traces is also going to produce metrics on the top of the traces. With OpenTelemetry Metrics, it's exciting because we can create our custom metrics, so we can think of technical KPI very specific to our code, or like I said, functional KPI, or even business metrics. So I think it opened doors to extend the observability to keep track on our application, on how is it working, and also maybe be able to create the SLO that we were looking for to track the health of our system. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.